students, last lecture we completed chapter number 11, which was solutions to algebraic and transcendental linear equations as well. So we learned four different methods there. First being as per your syllabus, first was Newton-Raphson, then was regular Falsi, the third was Gauss-Jacobi's, and the fourth was Gauss-Seidel. I took Gauss-Jacobi first, then Gauss-Seidel, then regular Falsi, and then Newton-Raphson. Okay. So today, starting with chapter number 12, which is expansion of functions. Okay, now what do you understand by this? There are different techniques. Your syllabus is limited to two different methods. One is using Maclaurin series and the second one is Taylor series. ठीक है, तो दोनों टाइप के क्वेश्चन चेक करेंगे हम कैसे यूज करना है, क्या करना है. That's the technique, and easy. You're just going to deal with derivatives, and that's it, right? So let's understand. The first one which we're going to start with is like today's lecture. This lecture I'm going to be dedicating it to Maclaurin series. So before starting with any questions on Maclaurin series, let's understand what is the formula for Maclaurin series and then we'll apply it. So the function which is given to us, say maybe the variable is x, so f of x over here is equal to f of 0 plus x times f dash of 0 x squared by 2 factorial times f double dash of 0 x cubed by 3 factorial f triple dash of 0 and so on. This goes on till infinity. Okay, so this is your formula for Maclaurin series. You need to remember this. Fine, it's an infinite series. It will have infinite terms. Now, how to expand a given function using Maclaurin series? We'll understand this with the help of some examples. And then we'll derive some standard formulae. Also, we'll be solving some questions based on these standard formulae. Okay, so let's start with some examples. Over here, the first question here says using Maclaurin series, to prove sec of x is equal to 1 plus x squared by 2, 5 times x raised to 4 by 24, and so on. Okay, so this is what we expected to prove using Maclaurin series. Let's see how do we manage to prove it. Now let's understand the term on the left hand side is your f of x. So f of x here is sec of x. Okay, observe Maclaurin series. If you observe the right hand side आपका expansion है फिर, ठीक है. लेफ्ट हैंड साइड आपका फंक्शन है, राइट हैंड साइड आपका एक्सपांशन है. चैप्टर का नाम एक्सपांशन ऑफ फंक्शंस है, तो आपको बेसिकली फंक्शन को एक्सपांड करना है. तो आपको राइट हैंड साइड के फॉर्म में लिखना है. ठीक है, द फॉर्मूला इज इन द बॉक्स. तो राइट हैंड साइड के फॉर्म में लिखने के लिए आपके पास क्या क्या होना चाहिए? आपके पास एफ ऑफ 0 होना चाहिए, एफ डैश ऑफ 0, एफ डबल डैश, एफ ट्रिपल डैश. मतलब आपको डेरिवेटिव लेते जाना है इस फंक्शन में. ठीक है, सो पहले तो एफ ऑफ 0 कैलकुलेट कर लेते हैं. So f of 0 here, okay, let's do it here itself. F of 0 will be sec of 0, and you can use your calculator and check. Of course, you have to keep it on radian mode. Okay, sec of 0 is 1. Sec 0 is 1 upon cos 0 basically. So 1 upon cos 0 is 1. So 1 upon 1 is 1 again. Okay, so f of 0 मिल गया हमारे लिए. Second thing we need to find is f dash. So sec का डेरिवेटिव होता है sec into tan. Sec का डेरिवेटिव होता है sec into tan. f dash में जब 0 डालोगे आपके पास होगा sec 0 into tan 0. अब यहाँ पे tan 0 is 0, so I'll actually get 1 into 0, which is 0. Now let's calculate f double dash. Now let's understand. While applying f double dash, I'll have a UV rule. दो terms है ना x वाले. So फर्स्ट को u ले लेते हैं, सेकंड को v ले लेते हैं. तो uv rule of derivative u as it is, derivative of tan x is sec square plus v as it is, derivative of sec is sec into tan. इसको थोड़ा सा सिंप्लीफाई कर लेंगे. So you'll have sec cube x plus sec x tan square it. Again f double dash of 0 calculate करेंगे. So that will be 1 का cube plus 1 into 0 का square. So answer is again going to be 1. I hope things are clear so far. Now f triple dash. ट्रिपल डैश मतलब थर्ड डेरिवेटिव, मतलब सेकंड डेरिवेटिव का वापस डेरिवेटिव लोगे. सेक क्यूब का डेरिवेटिव क्या आएगा? एक्स रेज टू एन का फॉर्मूला लगाएंगे पहले. तो एन एक्स रेज टू एन माइनस वन मतलब 3 सेक स्क्वायर एक्स हो जाएगा. जिसको एक्स अज्यूम किया है, एक्स रेज टू एन का फॉर्मूला लगाया, तो जिसको एक्स अज्यूम किया है उसके डेरिवेटिव से मल्टीप्लाई करेंगे. दैट इज कॉल्ड चेन रूल. So I'll multiply by the derivative of sec x, which is sec x into tan x. I hope things are clear. Again, second term here. This is basically what we are derivative, like, ये first term का derivative यहाँ पे. Now we want to take the derivative of this term. So u and v. Okay. So sec x का uv rules to sec x as it is. Tan square x, again x raised to n का formula 2 tan x. अगेन x जिसको अज्यूम किया है या वेरिएबल जिसको अज्यूम किया है उसके डेरिवेटिव से मल्टीप्लाई करोगे तो tan x का डेरिवेटिव है sec square x. Chain rule we are applying. Okay. This was u derivative of v. Now v derivative of sec is sec x tan x. Let's simplify. 3 times sec cube x into tan x. This is my entire first term. This is my entire second term, which is again 2 times sec cube x into tan x. And the last term has sec x into tan cube x. Let's calculate f triple dash at 0. So we know tan x becomes 0, tan 0 becomes 0. So जहां जहां tan है वो सारे टर्म 0 हो जाएंगे. If you observe तीनों टर्म्स में tan है मतलब ये पूरा टर्म 0 हो जाएगा. पूरा टर्म 0 हो जाएगा. Correct, no? You will have 0 here, you will have 0 here, you will have 0 here, and all the three terms will be multiplied by 0. So 0 plus 0 plus 0, which gives me a 0. Okay. Let's go for fourth derivative. Again, we'll have to apply UV rule. Okay, before going to the fourth derivative, I think I can simplify this a little more. I can write this as 5 sec cube x tan x. Observe this term and this term are exactly the like terms. दोनों में sec cube x tan x है, तो 3 plus 2 will give me 5 and the next term will remain the same. Sec x tan cube. Okay. So fourth derivative u v. So 5 constant u as it is. tan x का डेरिवेटिव हो जाएगा sec square plus v as it is. Sec cube का डेरिवेटिव लेंगे 3 sec square into derivative of sec, which is going to be sec x tan x. Chain rule. Plus again u and v. Okay. Let me use a different color so that it's not creating any kind of confusion. Okay, this is sec cube, this is tan x, this is tan cube. Okay, so this was my u here, this is a v, this is again u, this is again v. Again, we're going to apply uv rule for the second term. So u as it is, Tan cube will be 3 tan square. Again, tan x का derivative, that is going to be sec square x. Plus b as it is. Sec x derivative will be sec x tan x. So the derivatives are completed. Now let's simplify them. And let's observe the question. The question has up to x raised to 4. And if you observe Maclaurian series, if you observe the Maclaurin series which is in the box, each power of x is with the same derivative. मतलब x के साथ first derivative, x square के साथ second derivative, x cube के साथ third derivative. So x raised to 4 के साथ fourth derivative है. तो क्वेश्चन में हमारे पास x raised to 4 तक दिया है, मतलब आपको फोर्थ डेरिवेटिव तक कैलकुलेट करना है. ठीक है, तो यहाँ पे फोर्थ डेरिवेटिव एट 0 कैलकुलेट कर लेता है, सो दैट मैक्लॉरिन सीरीज में डाल पाएंगे हम लोग. सो अगेन यहाँ पे 5 टाइम्स 1 का क्यूब होगा इंटू 1 का स्क्वायर प्लस बाकी सारे टर्म्स इफ यू कैन ऑब्जर्व इट इज गोइंग टू बी 0. जहां जहां tan है वहां पे सब 0 हो जाए. ओके, सो आई एम लेफ्ट विथ 5 हियर. आई एम लेफ्ट विथ 5 हियर. आई होप दिस इज क्लियर. And we can have infinite such terms. We'll not get into infinity. We'll just put dot dot here. And we'll apply Maclaurin series now. So we'll write by Maclaurin series. By Maclaurin series, f of x is f of 0, x f dash of 0, x square by 2 factorial f double dash of 0, x cube by 3 factorial f triple dash of 0, x raised to 4 upon 4 factorial f fourth derivative at 0 and so on. I'm writing it directly till fourth derivative only because that's what we want. X raised to 4 तक चाहिए ना. तो अब f of x की जगह पे let's replace by sec x. That's the first line you can see. Fx is sec of x. F of 0 we have calculated here. F of 0 we have calculated here as 1. So f of 0 की जगह पे 1. X as it is. F dash of 0. F dash of 0 is here. Correct now? So that's we've calculated as 0. Then x square by 2 factorial इसके साथ f double dash of 0 यहाँ पे है 1 again. x cube by 3 factorial के साथ f triple dash at 0 which is here and we've got a 0 there. x raised to 4 divided by 4 factorial के साथ fourth order ये रहा. So that's 5. Let's simplify. 0 वाले terms गायब हो जाएंगे. So x square by 2 factorial x raised to 4, okay, 5 times x raised to 4 and 4 factorial is nothing but 24. Now why am I writing it like this? Because question में जो हुआ था पूछा है prove that part, उसमें factorial नहीं डाला है. See this, you can observe question में जो पूछा है वहां पे factorial नहीं डाला है, तो हम भी आंसर में factorial नहीं डाला. I hope we have got this. So this is hence proved. Hence proved. I hope everyone has understood what we have done here and how did we get the Maclaurin series of sec of x. Okay. Now if this is clear, we'll move on to the next example. So let's look at what is asked in the second question. The question says, okay, the previous question was asked in the university paper of 2018. Okay, it will not be more than 5 marks question because it's just finding four derivatives and just putting in the values. So it's not going to be more than 5 marks question. Okay. Next question. Prove log of sec x is x squared by 2, x raised to 4 by 12, x raised to 6 by 45, and so on. Now, this question was asked in the university papers of 1999, 2003, 2009, 2011, 2014, 2015, 2018. So you can see how many times the question has repeated. So let's begin with the question. I'll start with let y equal to fx is log of sec of x. The left hand side is always your function f of x, and I'm using the symbol y here. You will understand why I'm using y a little later. Okay. So step number 1, f of 0. So log of sec of 0, which becomes log 1, and log 1 is 0. Log 1 is 0. Let's go for y1. If you remember, in the chapter of successive differentiation, when we wrote y1, it meant first derivative of y. It means first derivative of y. So the derivative of log is 1 upon the function, and chain rule sec x ka derivative sec x into tan x. So this gets cancelled. I am left with tan x. We'll calculate f dash of 0. So that becomes tan 0, which is 0. Observe, you need to calculate up to the 6th order. Okay, x square, x raised to 4, x raised to 6. So you have to calculate up to the 6th order. So let's go to y2 now. y2 is f double dash. Derivative of tan. Derivative of tan is nothing but sec square of x. Okay, so f double dash at 0 is going to be sec 0 square, which is going to be 1 square, which is 1. y3 will be f triple dash. That's going to be 2 sec x into derivative of sec x is sec x tan x. So I'll have a 2 sec square x tan x. So f triple dash at 0 will be 2 times 1 square into 0. Tan 0 is 0. Okay. So the answer is 0 because of multiplication by 0. Fourth order derivative. We'll have to apply UV rule. So that's going to be 2 times u as it is. Derivative of tan is sec square plus v as it is. Derivative of sec square is 2 sec x into, by chain rule, sec x derivative is sec x tan x. On simplifying, I'll get 2 times sec raised to 4x plus 2 times sec square x tan square x. I need to calculate the fourth order derivative at 0 for the Maclaurian series. So when I do that, I'll get 2 times 1 raised to 4 plus 2 times 1 square into tan is 0 square. So I'm left with 2. Let's calculate the fifth derivative. Okay, yeah, I don't think I can simplify this any further. Means even if you use identities, it's going to be like more complicated. Okay, the fifth order derivative. So 2, okay, this I can write as 2 sec raised to 4x plus 4 sec square x tan square x. Okay. So the derivative of the first one will be 2 into 4 sec cube x into derivative of sec x, which is sec x tan x, plus this will be UV rule, 4 times u as it is. Tan square derivative will be 2 tan, and derivative of tan is sec square, plus v as it is, that is tan square as it is. Derivative of sec square will be 2 sec x, and derivative of sec is sec into tan, chain rule, okay? Now I need to simplify this because I need the sixth order derivative also. So the first term turns out to be 8 sec raised to 4 x tan x plus 8 sec raised to 4 tan x again. Okay, sorry, this is sec raised to 4. And the next one is again 8 sec square x and tan cube x. So the first two terms get added and we get a 16 sec raised to 4 tan x. And the last term remains as it is. When I calculate f fifth order derivative at 0, because both the terms have tan, answer will be 0. Let's calculate the last derivative, that is y6, which is the sixth order derivative here. 16 constant, again u, okay, there should be x here, v here, again u here and v here, okay? So one at a time. So the first one, I'll have u as it is. Derivative of tan is sec square. V as it is. Derivative of sec raised to 4 will be 4 sec cube. And derivative of sec would be sec into tan. Second term, which has a 8, u as it is. Derivative of tan cube would be 3 tan square. And derivative of tan would be sec square. Plus v as it is. Derivative of sec square would be 2 sec x. And derivative of sec would be sec into tan. Let's calculate directly the sixth order derivative at 0 because we don't want further derivatives. We'll just take a little shortcut here. So wherever there is tan, all the terms will become 0. Like this term will become 0 because of tan. This term will become 0 because of tan. This term will become 0 because of tan. So only the first term is going to give me the value, that is 16 times 1 raised to 4 and 1 raised to 2, that's 16. Okay. Now let's apply Maclaurin series. Let's apply Maclaurin series. My f of x would be f of 0, x f dash of 0, x square by 2 factorial f double dash, x cube by 3 factorial f triple dash, x raised to 4 by 4 factorial fourth order derivative, x raised to 5 by 5 factorial fifth order derivative, and x raised to 6 by 6 factorial sixth order derivative, and so on, and so on. We write it up to sixth order because we require up to sixth order as per the question. So let's substitute the values. Fx in this question was log of sec x. So the left hand side would be log of sec x. Okay, let's start with f of 0. F of 0 here is 0. Next is 0. Then you have 1. Okay, so the first two terms will be 0. First two terms are 0. So you have a 0 plus x times 0 plus you have x square by 2 times 1. X cube by 3 factorial is 6 into f triple dash. F triple dash is here. 0 again. So 0 here. X raised to 4 upon 4 factorial is 24. So multiplied by fourth order derivative. Fourth order derivative is 2 here. So I'll be multiplying by 2. X raised to 5 by 5 factorial is 120. Into the fifth order derivative is 0. X raised to 6 by 6 factorial, which is 720, multiplied by 16. Multiplied by 16. So let's simplify. The first two terms, because they're 0, we don't count them. X squared by 2. Fourth term is again 0. Fifth term becomes x raised to 4 by 12. The next term is 0, and then you have x raised to 6. Okay, let's cancel the 16 and 720. So I do it with the table of 4. I'll have 4 180s, and again when I do it with the table of 4, I'll have 4 45s. You can always use your calculator. And okay, let's not stop there. We always need to put a plus dot dot dot. Okay, so let's see what we were supposed to prove. Have we got that? X squared by 2, x raised to 4 by 12, and x raised to 6 by 45. Same thing. So this is hence proof. Hence proof. Now if you understand, things are not very difficult. Okay, they're easy, they're simple. It's just that you need to take derivative, little patience, थोड़ा सा आराम से करना है, mistakes ना हो, silly mistakes ना हो, और x की जगह 0 डालते जाना है. That's it. Okay, that's what Maclaurian series is all about. Let's take one more example. So the question says using Maclaurin series, expand log of 1 plus e raised to x in powers of x up to x raised to 4. Now this question was again asked in 1995, 97, 2001, 2002 and 2006. Let's see how do we deal with this particular question. Whatever you have to expand, that will be your fx. So fx की value हो जाएगी log of 1 plus e raised to x. अब क्वेश्चन में बोला है पावर्स ऑफ एक्स, तो हमारे पास जो आंसर आता है, जो प्रीवियस आंसर्स देख लो सारे, वो सारे पावर्स ऑफ एक्स, एक्स स्क्वायर, एक्स रेज टू 4, एक्स रेज टू 6, ये सारे एक्स के पावर्स है. आपको क्वेश्चन में बोला एक्स रेज टू 4 तक जाना है, मतलब फोर्थ ऑर्डर डेरिवेटिव तक जाना है इनडायरेक्टली. ओके, अब इसको y ले लेते हैं. लेट्स स्टार्ट विद द फर्स्ट डेरिवेटिव f डैश. अच्छा, उसके पहले f ऑफ 0 कैलकुलेट करना है मैक्लॉरिन सीरीज के लिए. सो दैट विल बी log ऑफ 1 प्लस e रेज टू 0. x की जगह 0 डालना है. ओके, so that's log of 1 plus 1, which is log 2. So this log 2 will remain as it is. You cannot change it. It's log 2. Okay. You don't need to even calculate the value using calculator or anything like that. You just leave it as it is. Okay. So that's your f of 0. Next, let's calculate f dash. So 1 upon 1 plus e raised to x. Chain rule लगाना पड़ेगा. So chain rule से 1 का derivative 0 and e raised to x का e raised to x. So I have e raised to x upon 1 plus e raised to x. Okay, so that's your first derivative. So f dash add 0. So e raised to 0 divided by 1 plus e raised to 0. That is 1 upon 1 plus 1, which is, let's now calculate y double dash. So to calculate y double dash, we'll have to use u by v rule. So as you can see, the numerator is u and the denominator is v. And we'll apply v derivative of u minus u derivative of 1 plus e raised to x is e raised to x only. Denominator square, which is 1 plus e raised to x the whole square. Let's open the brackets. This is e raised to x the whole square basically. So how do I calculate that? E raised to x square becomes e raised to 2x. Why? Because a raised to m the whole raised to n is a raised to m into n. Okay? So e raised to 2x minus e raised to 2x again. So this gets cancelled and okay, the first term is e raised to x, not 1. And you'll have 1 plus e raised to x the whole square. So we are left with e raised to x upon 1 plus e raised to x the whole square. Understand e raised to 0 is always going to be 1. So when I have to calculate f double dash at 0, I'll have 1 upon 1 plus 1 square, which is 1 upon 4. 1 upon 4 in this case. Okay. So let's now move to the third derivative. We are expected to find up to the fourth order or the power of 4, x raised to 4. So we'll go to the third derivative and then slowly to the fourth one. Okay. So again, u by v rule, u here and v here. So that's going to be v as it is. Derivative of e raised to x is e raised to x minus u as it is. The derivative will be 2 times 1 plus e raised to x into chain rule e raised to x. Divided by 1 plus e raised to x the whole raised to 4 I'll get because square of square. Let's observe this 1 plus e raised to x is common. So I'll take it out. So from the first term, because there's a square, ठीक है square है तो यहाँ से एक बाहर गया एक अंदर. So one of the 1 plus e raised to x will remain inside. E raised to x is already inside. Minus 2 times e raised to 2x. Why e raised to 2x? Because e raised to x into e raised to x. Okay. And the denominator is 1 plus e raised to x the whole raised to 4. Now understand numerator में एक बार है यहाँ पे 4 बार है तो 1 will get cancelled and we'll be left with 1 plus e raised to x the whole cube. Numerator will become e raised to x, e raised to 2x minus 2 e raised to 2x. Okay. So now that becomes, on simplification, e raised to x as it is minus e raised to 2x upon 1 plus e raised to x the whole cube. Let's substitute 0 in place of x. So triple dash at 0. Wherever there is e raised to x or e raised to 2x, it will be 1. So 1 minus 1 upon 1 plus 1 the whole cube. Answer is 0 because numerator is 0. Let's now calculate the fourth derivative. That's the last one. Again, u by v rule. So u here and v here. So v as it is. Derivative of e raised to x is e raised to x minus as it is e raised to 2x is this. And by chain rule, you'll have a 2. Minus numerator as it is. Derivative of the denominator is 3 times 1 plus e raised to x the whole square and chain rule e raised to x will come in. Now we have 1 plus e raised to x, the whole raised to 6 it will become. Let's understand, we'll not simplify this because we want up to the fourth power. So we just want at the fourth derivative, what is the value? Like if fourth order derivative at 0. Okay, if you want, you can simplify, but then I'm going to skip that part. I will just replace all of the e raised to by 1, e raised to x, e raised to 0 by 1. So 1 plus 1 cube, 1 minus 2 times 1, minus 1 minus 1 into 3 times 1 plus 1 square into 1. Denominator 1 plus 1 the whole raised to 6. The numerator becomes 2 cube into 1 minus 2 minus, observe the second term becomes totally 0. ये 0 है ना एक bracket और सारे terms multiplied by 0 है तो 0 हो जाएगा. Denominator will become 2 raised to 6. Now 2 cube and 2 raised to 6 will get cancelled. Numerator पे minus 1 upon 2 cube बचेगा, मतलब negative 1 by 8 बच रहा है. Okay. So let's apply Maclaurin series again. Let's apply Maclaurin series. So by Maclaurin series, we'll have f of x is f of 0, x f dash of 0, x square by 2 factorial f double dash, x cube by 3 factorial f triple dash. फोर्थ ऑर्डर तक लिखेंगे बिकॉज x raised to 4 के टर्म्स में बोला है क्वेश्चन में. ओके, एंड द सीरीज डज नॉट स्टॉप हियर, इट इज इनफाइनाइट. चलो लेट्स सब्स्टिट्यूट द वैल्यूज हियर. f of 0, f of 0 is log 2. Okay, you can observe here log 2, 1 by 2, 1 by 4, 0, and then we have a negative 1 by 8. Okay, sure. Let's substitute. So first value log 2, x times f dash पे हमारे पास 1 by 2 था, x square by 2 factorial मतलब 2 हो जाएगा ये, and f double dash was 1 by 4, triple dash पे 0 था, and x raised to 4 upon 4. Okay, 3 factorial को भी replace करते हैं 6 से. 4 factorial is 24, and यहाँ पे we have negative 1 by 8, and this goes on. Okay, so when I simplify, I'll get log 2 x by 2 x square by 8, 0 को नहीं लिखेंगे, negative x raised to 4 divided by 24 into 8. So that's going to be 192. And this goes on. The question asked you expansion up to x raised to 4. So this is your valid answer. This is your valid answer. And this was the expansion of log of 1 plus e raised to x. Okay. I hope the question is clear with all of you. And how to handle Maclaurin series is also understood by all of you. Now we'll be going on with the standard function expansion. We'll be first deriving few of them, not all of them, and we'll be using them to solve questions. Okay, so for today we